All right. Hello, everybody. Welcome back to Comp 2450. I hope that you all had a very good weekend. Today, what I want to do is I want to spend a little bit of time kind of stepping back and taking a look at this idea of records. And then what I want to do is I want to start us working on another part of the course. So I want to give you an idea of like some of the ways that this course is going to work in terms of like the flow or the cycle of what we're doing. At the very beginning of the course, our goal was basically, I want to spend some time doing a little bit of design before I start writing code. And the design part of the initial part of this course was very much like, how do I take this big idea that I've got and get these ideas from that thing and represent them as classes in code that I'm eventually going to write. Once we did the plan, and I want to kind of think back to this idea of this plan of our domain model, we had something that was an abstract representation of the idea, but we hadn't really thought anything about programming languages. And that was one of the cool things I think about this idea of doing design up front, is that the things that we're doing with our design don't really have anything to do with the programming language that we're eventually going to use for this. And so a lot of the stuff that we were doing with design here, you could take the same design and re-implement this in C++ in Comp 2400 if you wanted. I don't think you want to, but I think you could. You could take this and do this in JavaScript. You could take this and do this in Python if you wanted, because we really weren't thinking too much about the technical details of the programming language that we were working with. Once we got that basic design, then we did start to take that and started to encode some ideas of programming languages. And we started to think about how we would take these different types of structures that our programming language provides us and use those to encode the ideas that we've got. Now we're going to go back to the design phase. And the design phase that we're going to be starting to look at today is the domain model that we've got doesn't do anything. It doesn't do anything. Like, it's just a bunch of classes. And I've asked you to do some stuff that will allow your graders to make instances of those classes, but you haven't made a game, and you haven't made a library that works, and you haven't made an exercise or activity tracker that does anything. Now I want to start thinking about, how will people actually use this thing that we're building? How is my parent, how is my mom or my dad or my siblings, my brother, how are my children going to use the software that I'm going to write? And I want to think about that before we start writing code. And so the exercise that we're going to be starting to go through this week is to restart this cycle. We've done design, we did a bit of implementation. Now we're going to go back to design before we start doing more implementation. And so the thing that we're going to spend some time on today is introducing this idea of flows of interaction. So how can we start to think about and formalize some ideas around what a person is doing when they are actually interacting with our software? And one thing I want you to think about, and may not say this explicitly again, but one thing I want you to think about as we're doing these flows of interaction is, we're not talking about programming languages. That's one thing. But we're also not actually talking about display technology when we're doing this. I'm not going to be talking about GUIs versus text interfaces. I'm going to be talking about things like inputs and outputs. And I'm going to be talking about things like what the machine or what the computer is doing at certain points, what the person might be looking at in terms of what we're expecting to get from them. But I'm not going to be talking about this as being a text box or like scanner or anything like that, because we're not thinking about our technical details again. We're kind of focusing on how somebody is going to get through this application to accomplish tasks that they want to accomplish with this thing. So what I want you to do, what I want you to be able to do by the end of the day is, again, I want to spend some time revisiting this idea of records. And so I want to continue with this learning outcome. Choose and use appropriate language structures for representing domain model objects. And then what we're going to do is to start introducing this idea of sketching our flow of interaction in an interactive system before implementing it. There are two things that I really want you to be able to do by the end of today's lecture. The first is, I want you to start being able to identify tasks that are part of interactions with software, given detailed description of the software. I'm going to stick on this word task. I'm going to keep using this word task. I'm going to try to define this word task for you. We're thinking about tasks here. I want to accomplish something. I want to do something with this software. So I want to focus on this idea of a task. And I want you to be able to informally sketch the flow of interaction for a system. So I want you to start being able to take this high-level description of a system and start putting pen to paper today, and to be able to take these different parts of this whole task idea and draw this out in a way that's consistent for all students in this class and consistent for people that are grading the work that you're doing. But the idea is I want to take this high-level task and start to model. I want to define what somebody's going to do when they're working with the system that they have in front of them. This weekend was pretty busy for me. My daughter was invited to a birthday party, but it was a birthday party that was like nothing I've ever experienced before, in like the most positive way. It was amazing. She was invited to this birthday party. It was for a little kid, so somebody that's less than 10 years old. And there were 100 people there. It was intense. I have never been to a birthday party like this before, and they like booked half of a restaurant, and it was this big, big thing. The kinds of birthday parties that I'm expecting these days, and this is like an incredibly unrelatable story, so please forgive me about this, but the kinds of birthday parties I'm expecting these days are like, I'm going to drop my daughter off and then go do shopping or something. Like, that's my life. That's where I'm at in my life right now. So to get to this place that's like half a restaurant and there's 100 people there, and like this is like families that are getting together to have this birthday party was, I don't know, it was really cool. It was nice to see that. That has nothing to do with anything about what we're talking about right now, but yeah, I'm a real person. I do stuff like that on the weekend. So let's talk about records, let's talk about immutability, let's talk about data and information, and let's talk about real things. I feel a little bit, and I got some feedback from you, that when I left this conversation of records, like a good rule of thumb, I wanted to give you a good rule of thumb of how you should make decisions about what you should do when you're thinking about choosing a record type. And the rule of thumb that I gave you was thinking about things like primitive types. If this is just a class that has a bunch of primitive types in it, that's a pretty good reason to choose a record type. When I gave you a quiz on this, one of the things that I asked you to do was think about this idea of a student. And one of the problems with me asking you to think about this idea of a student and the primitive types that I listed is that students are people. And things like names of a student change for lots of different reasons. Different properties that are attached to people will often change in real life. And so that doesn't necessarily reflect the idea of what I was trying to get across with record and the idea of immutability. And so I want to spend just a little bit more time today thinking about these different ideas and trying to disentangle these things from each other, because right now it sort of feels like they're kind of squished up into a little bit of a ball of spaghetti here. So, people and information. People can change. I think that's obvious to everybody in this room. People can change. But separate from people and people changing, we have this idea of data or information about people. And I want to separate these two ideas into two different things. I am a person, and you are all people. I have data about you, and I want to make it very clear that this is just like minimal data. Like I have your name and student number. I have information about you, your name and student number on my machine. These are two different ideas. Aurora, the university, has information about you. They have things like your address, and I know this because I was a student that went here, and when I log in to Aurora, I can still see my own student records. I don't like to look at those very often, but I can still see them, and they have my addresses of many years past, like apartments that I've been through when I lived with my dad still, when I was a 19-year-old kid coming to campus here. Data and information about people and people are two separate things. And in general, data and information about an object or a physical thing in the real life and that physical thing in the real life, they're two separate things that we're thinking about here. The kinds of information that we have about people or that we're thinking about with people are things like names or a name or names, our age, preferences that we might have. So I'm thinking about preferences of like, I've logged into this website and I wanted to show this or not show this. Those are the kinds of preferences I'm thinking about, and lots of other stuff, like I said, like addresses that you might have over time. The data and information that we're collecting here are often stored in inert places. When I use the word inert here, what I mean is that they just kind of sit there. They don't do anything. They're not actively participating in anything. Data and information just sits in a file. It sits in a database, and it doesn't really do anything until a person is starting to ask questions about that database or that file. I'm going to open it and read it. Or alternatively, I'm going to use programming languages to ask questions about the data that's in that database at some time. So it's otherwise just kind of sitting there. Over time, these files and databases are changed to reflect the changes in people. So like I said, as I am moving around and changing from being a student, an undergraduate student, to a graduate student, to a faculty member, the addresses that I have in Aurora are changing over time. My student number never changes, and my UMNet ID never changes. They're always the same, but my address kind of changes over time. My dependents change over time, and that information in those places in files and databases is being changed. When I am thinking about instances of objects, so I've defined this class that is an abstract representation of a person or a real life thing, I am often thinking about this idea of an instance of this class. Instances of classes contain data or information about a person or a real life object, but it contains that information from an instant in time. This is going to reflect the state of something that's in a file or in a database, whatever it happens to be right now, whatever that information happens to be right now, but this is something that's just an instant in time. The way that we get that information into our instances of objects for that instant in time is to do things like loading the data from a file. So in Comp 1020, you spent lots of time reading files. I actually don't know what you've done in 1020. Did you use file types like CSV? Or was it just like lines? Just lines. So did you have records? Did you have idea of records like line 1 is this thing? No, just straight up lines of files, just plain text. Okay. Okay, so delimited text, some kind of delimited text to represent information. All right, awesome. So you have experience with this. You're reading a line of this file, and then you're creating an instance of an object based upon the information that you've read from that line. The same thing is true for databases. Databases are these, for us, at least in Comp 2450, this big kind of question mark technology. A database is a thing, and we can ask for information from it, but we're not really sure too much about that. We'll talk more about this in Comp 2452 when we get there. Ultimately, though, information about real life things gets loaded into instances of objects through a file or through something like a database. Changes can be written back to that file or database. I can read a line from the file, I can delete it, or I can make a new file to reflect the changes that have been made to that real life thing. And that's not necessarily going to be coming from the instance of the object that I have. if I am making changes to values in an object, it doesn't necessarily mean that the object instance itself is going to be used to put those changes to the database or the file. And so what I mean by that is somebody in the registrar's office, I don't believe that they do this, but someone in the registrar's office could open the file that is students.txt that's 15 gigabytes in size, find the line that represents you in their text editor, and then change that thing. They don't do that. They don't do that for the record, but just to give you an idea. The changes that we have in these information stores can be made by something that's outside of an instance of an object. It can be done in code, but it might be made outside the instance of the object. Records and immutable objects in general, and so I want to be clear that a record is not the only kind of immutable object that we can have. A class can be immutable. Making a record is a convenient way to have an immutable object, but you can make classes themselves immutable as well. If you don't provide any kind of mutator to a class, it's an immutable class effectively. If you forbid yourself internally from making changes to the properties that you have in your class, it's an immutable object. If you use that final keyword on everything and you never make changes to your lists, it's an immutable instance of an object. A record is a convenient way to get an instance of an immutable object because it forces you to have everything final. It does not provide mutators at all. It does a lot of the heavy lifting for you in terms of that, but it gives you an immutable object. Using immutable objects, whether they are records or whether they are classes, is really about specifying the intent of use of that instance. The intent of use here is meant to be something that I, as a person writing software, am trying to communicate to you, people who are reading or using the software that I have written as technical folks. I've made a library and I'm creating a record. I am telling you that when you use that record, you should either accept or understand certain things about that, which are things like, you can't make changes to this once I have passed you an instance of this. There are two ways that I want to think about using records and using immutable classes here. Accepting a record as an argument to a method. So when I have declared a method and I'm asking you to pass to me an instance of the record type, what I am effectively telling you, what I am communicating my intent to be is that I've written this method. I promise that the thing that you pass to me, I'm not going to make any changes to it, kind of because I can't make any changes to it. If it's immutable, I will not be permitted. There are no mutators. I cannot call a method to make changes to this thing. So I can promise you that by the end of me running this method, the class instance that you pass to me will still be the same. Nothing about it will have changed at that point. The other thing is, and this is kind of related to this idea of design by contract, I'll say this again later, but I want to stop myself. I don't trust myself to not make changes to the instance of this object that you're passing to me. So I'm going to forbid myself from making changes to it. And the way I'm forbidding myself from making changes to it is that I can't make changes to something that's a record here. I won't be allowed to. I'm not going to be permitted to do that because these methods, at least with a record type, don't exist. I cannot call a mutator on a record instance here. So as an example, if I have made this type of a record here called immutable thing up here, what I'm effectively saying as if I'm accepting this as an input, as an argument to this method, I don't want to be able to make changes to this. If this method is purely for persisting an instance of this object to the database or writing it to the file, me doing that should not cause changes to that instance of the object. In terms of the lifetime of the data that we have here, the lifetime or the scope of the instance of this variable, the lifetime or scope of this thing is outside this method. Someone will have passed this to me. That means that someone will have constructed an instance of this in some other method, like in main. But the lifetime of this variable is like milliseconds, tiny fractions of a second in terms of how long this instance of an object exists. The goal again here is I don't want to make changes. I'm telling you that I'm not going to make changes to the instance that you pass to me, and I want to forbid myself from making changes to this instance because the thing I'm going to do, the operation I'm doing, should not change anything about what you're passing to me. The other option here is if I'm giving you back an instance of an immutable class. So I'm returning something from a method that is an instance of a class, an instance of a record, sorry, or some other kind of immutable object. What I'm effectively saying here is that I'm going to give you something that represents some kind of information that I got, and I don't want you to make changes to that thing because I might be using it later, and I don't want you to have made changes to it. I don't want the person that's calling this method to make changes to the data, so I'm going to forbid them from making changes to the data by making this class an immutable instance, either by doing record or by making this an immutable class. So, as an example here, if I have a printer class or some kind of other method that's responsible for displaying something, what I really want to be able to say is that this immutable thing that I've declared here as a record, I want to be able to load information about that from the database. So do something here, get that information from a file or from some external service that I'm interacting with. I'm going to create an instance of this immutable type, and I'm going to return it to you. And I don't want you to make changes to it. I don't want you to make any changes to this thing right now because your goal in this display or show method is really just to print stuff out about it. I don't want that to happen. The lifetime or scope of this variable instance that I've gotten from this get method now is going to likely be limited to the end of the method that it was returned to. So it's just going to get garbage collected after that and kind of disappear. It's possible that this is also going to represent information about that class that we don't want to have it changed later. And we keep references to that inside of our class. But the example I want to stick with here is I'm loading something from the database. I really don't want you to make changes to that when you're showing it. And then I'm going to let you let that thing fall out of scope here. So the lifetime ends when this method ends. This whole idea of immutability, I want to reinforce this idea. This is about communicating intent. It's a lot less about how things change in real life. It's a lot less about data and information changing in real life. It's a lot more about communicating the intent of what we want someone using this class to be able to do with an instance of this class. So just like with design by contract, we're effectively taking these assumptions that we're making. I don't expect you to make changes about this instance that I'm returning to you. I don't want to make changes to this instance that you're giving to me. So I'm going to put that in my type system and forbid that from happening in the first place. So we're encoding and we're enforcing our assumptions here. With design by contract, this is class invariants that are happening at runtime. So when we're doing development of our code, we're writing these assumptions out, and we're making sure that our assumptions are not violated. Using types and using immutable types here is really meant to be a compile time thing. You can't call this method because it doesn't exist. And if you try to call this method, there's going to be some compile time error that's going to prevent you from even getting your code working in the first place. So we're not going to be able to get past this point. All right. So I do want to stand by my rule of thumb, which is if it's just a bag of primitive types, that's likely a good choice to use as a record. But really the idea of using records and immutable types is about communicating intent of what we want with these classes to the people that are otherwise using them. Are there any questions about that? Yeah. It depends. So the question is, a student shouldn't be a record. It depends. What I want us to think about when we're trying to make this decision is, what is our intent with this? And so if our intent with this is to load an instance of student from a database and then display it, then it's reasonable for that thing to be a record, because in that context, its properties are never going to change. If I have an actual student management system, maybe I want to have a record type that represents a student for when I'm displaying it. And maybe I want to have a separate class type for student when I do want to make changes to them. So if I'm loading something up that's going to be like show information about this student for the purposes of changing it, might have two different representations of the same abstract idea here. One's a record, I'm just displaying it, and one's a class. I expect you to make changes to this as part of the flow of interaction, which is where we're getting next, the flow of interaction of what we're doing with this thing right now. In terms of the projects that we're working on right now, my expectation is that you have one abstract representation of each of the big ideas that you have in your system, as opposed to many for different things. But that intent can change as applications grow and grow larger. Yeah. Yeah.
Basically, but I think it's always been one of our trivial classes that records have their automatically implement their own methods itself.
Records will automatically provide you with accessors to types. So like when I'm declaring this immutable thing type here, there's a method on instances of this record type called value. And what it returns is the integer for this thing as it's been constructed. There's a method that's called name, and it returns to us the value that that name property has. It also has a constructor that's automatically generated for it that will accept those arguments. It has a hash code implementation. Did you see hash code in 1020? Okay, so hash code is something that is used in the context of things like sets. It basically makes, are you doing 2140 right now or 2080 right now? 2140. Have you talked about hash tables yet in 2140? Okay, so you will talk about hash tables in 2140 eventually. You'll get there. The hash code is directly attached to that, and it's trying to find a unique location in an array that represents this thing. The other thing that it does auto-create for you is an equals method that will go through and it will compare each of the properties that you have in that type. So if you ask that question, it's going to like do a deep equals on the thing that you've got.
So automatically compare value and name, not like the object itself?
It should compare the values in the primitive types that you've got, yes, yeah. I don't know, I actually don't know if it will do dot equals on the string instance that you have here. I'm not sure if it will do this like recursively, but for primitive types like integers and stuff, it will actually compare their values to each other. Yeah. All right. Okay. So what I want to do now is I want to start going back to this idea of doing a little bit of planning here. So we've gone through this process of building up our domain model. We've built up this UML class diagram that represents the big ideas that we have in our system. And we've built up this big UML model or class diagram that represents some of the relationships and the types of relationships that we have between instances of these objects. We've gone through and we've started to take these ideas that we've encoded in this thing, and we've started to implement that in Java. And then one of the last things that we've done is effectively go through and take these classes and then explicitly state the assumptions that we have about them in terms of what it means for an instance of this thing to be valid from a development perspective. So applying this idea of a class invariant and starting to think about where we're calling that class invariant as a precondition at the beginning of a method or as a postcondition at the end of a method. And this is effectively one cycle of development that we're doing in this course. Planning our model, implementing our model, and now we're getting back to starting to plan something here. We've completed one cycle of development where we're going through and designing this domain model, and then we've implemented that thing. But it doesn't do anything. is just sitting there. You've got this REPL and you're making instances of objects, but that REPL is not Battleship. That REPL is not an activity tracker that I would use, and it's certainly not a library that I would ever want to go to. These are places and things that we've got right now that we can just make instances of classes, and we can't really interact with them in any meaningful way. What I want to do here is I want to start modeling how a person is going to interact with our software to accomplish the thing that our software is actually supposed to do. The way that we're going to do that is that we are going to model this thing called a flow of interaction. There are going to be many flows of interaction in the software that we've got. We're going to start by modeling just some small parts of these ideas of flows of interaction. For us in Comp 2450, what this is going to mean is that given an existing system, given a description of an existing system, so like Battleship is an idea that exists. Activity trackers, these are things that exist. Libraries, these are things that exist. Given ideas, given descriptions of existing systems, what I want you to be able to do and what we want to be able to accomplish here is ultimately describe how a person will interact with that system by identifying and then describing some different ideas. The first is the high-level tasks that this person interacting with our software will need to be able to accomplish. So a really big idea here. The really big idea I'm thinking about are things like I have a specific task. I want to play a turn. I want to borrow a book. I want to track the activity that I've just completed. A really big idea here that represents one small part of this thing. That one big thing is going to consist of a bunch of subtasks. These are small interactions that this person using our software will have to do to be able to accomplish this big task that we've got. I want to be able to identify the inputs that are required from that person to accomplish the subtask that they have. So I'm going to have these subtasks. The subtasks themselves are going to have the person using my software giving me something. They're going to enter information or they're going to choose things such that it causes something to happen in my system. I want us to be able to think about processing. And as I mentioned at the beginning of class, we're not really thinking about technical ideas here. We're thinking about how this person is going to interact with our system. We're not writing code here to represent what this processing is yet. We're going to say the computer needs to do this right now effectively. This is what we're trying to describe in plain English at a very high level. And finally, we're going to have outputs that are produced by this processing step. The flow here, similar to the cycle of development that we're going through, is that tasks and subtasks, these are things that people are going to see. They are going to provide us with inputs. That will then go to the machine. Our computer will do something. And then outputs will be produced by the system for the person using our system to start looking at. I want to see what the outputs from this thing happen to be. Yeah. That's a good question. The question is about packages. So should we have a new input package here? What we're doing here might wind up being several different packages. The several different packages that we might have here are going to be for tasks and subtasks. So this here might be something that is going to be on a per display type package. So if we're doing text output or text display, we might have a package for that. If we're doing GUI stuff, we might have a package for that. The processing here, this is going to be something that should be independent of the tasks, and it should be independent of ultimately the way that that's presented to the person that's using the system. What I really want to be able to start modeling and thinking about here is that I'm going to have these processing steps, and I ought to be able to change the way that the person's actually interacting with that. And so I'll have a package for processing that's going to be separate from these other things. And then I can have multiple different packages. One will be text display, one will be GUI display, that sort of thing. Yeah. So it's a good idea to start thinking about how you might organize this stuff physically. And it's related to packages, but it's not a directly one-to-one relationship between packages. Yeah. Yeah.
So does that mean a method that actually does processing shouldn't have anything to do with outputting something at the end of that processing?
Yeah, so that's a good question. The question here is effectively, should a processing method have nothing to do with output? And I'm actually going to point back at stuff that we've done already, which is the single responsibility principle. Something that does processing should not have the responsibility to also produce output as part of that processing. And I'm going to point back at some of the stuff that we thought about there for that reason of, if I have this processing and I want to be able to internationalize or localize the text that's in my software, I don't want that hard-coded English language string as part of the processing that I have here. I don't want to say that there won't be information that gets printed out for development purposes. So like I want to do some debugging and I want to see what the state of things are as they are progressing in the system. But for actually showing to the person that's using my software, I don't want that to be in the processing step. So the outputs here that I'm thinking about are going to be more like, these are passed to some other class or method that's responsible for actually showing that to the user. Yeah. Yeah. Your question answered? Okay, awesome. Okay. So I'm really delighted to hear you starting to think about taking some of these ideas and mapping them to packages and starting to think about things like, where does printing or where does display go in the system? And as we're doing that, I want to start being able to think about, like I said, single responsibility principle. And then I want to be able to think about, from the technical perspective, I want to start thinking about, let's switch these ideas out. We're going to be stuck with text-based interfaces for Comp 2450, but when we get to Comp 2452, we will switch to GUIs. And I want to start thinking about that sort of the thing now. So what I want to do to begin with, before we actually get into doing any of these exercises of coming up with these flows of interaction, is I want to make sure that when we're doing these diagrams, you and me and our grading staff are all speaking the same language about what these diagrams are going to look like. So we're going to use some agreed upon symbols when we're working with this for Comp 2450. The first symbol that I want us to think about is this idea of an entire task. An entire task is going to be something that we're going to represent as a really big kind of rounded rectangle shape. So it's rectangular in shape, but the edges of it are kind of rounded off here. An entire task is something that's going to enclose all of the subtasks, inputs and outputs between those different subtasks and all the processing steps that we have here. So this is the high level idea of the task that we're trying to accomplish, and it will contain all of the things that we're trying to accomplish as part of that or that are necessary to accomplish that task. I want to be able to have starting and ending subtasks. For each task that we have in our system, the person using our software will have to begin this interaction somewhere, and they will have to end this interaction somewhere. The way that we're going to represent these two ideas is using rectangle shapes that are double rectangle shapes. So this is where I am beginning to interact with my software for this task, and this is where I am ending the interaction. So I have accomplished the thing that I set out to accomplish. Inputs gathered by tasks or subtasks are going to be thick lines. The thick lines are going to be labeled with the things that we're trying to get from the person using our software at this step. In the same way that we started with our domain model not having any technical language, I don't really want to have any technical language here. You can refer to ideas that are in your domain model right now if you have a thing that represents this idea. But what we're really looking for here is effectively, what questions are the person that's using our software being asked right now? What are we asking them to provide to us as input so that we can begin to do processing? The processing step here is something that I want to represent as a diamond shape. And the processing here, when we're labeling this step in our diagrams, this is going to really just be like an extremely high level description of what we're doing here. So like 3 words. We're not thinking about detailed paragraph descriptions of what this thing actually accomplishes yet. And then finally, the outputs that are produced by processing steps are going to be dotted or dashed lines. And again, I want to have labels on this describing what the outputs are going to be. So what should happen as a result of this in terms of what our person using our software actually sees at the end? Within our tasks, we are going to have generally one starting place. I think that this is going to be, I'm actually struggling to come up with any example where there'd be more than one starting place, but there can be potentially more than one ending place here. So I've accomplished the task, but there are different ways that I can get to that point. Generally, though, we're going to have exactly one. We will have exactly one starting subtask and one ending subtask. So I want to draw these out. Again, I want to make sure that we are speaking the same language here, and I want to make sure that we all have the same idea of what I am trying to describe by these ideas. So I'm going to pop over here to my terminal. I'm going to start this again. There we go. So the things that I want us to be able to think about here are tasks. When I'm going to draw a task here, I'm going to do this as, this is all a big uppercase label, and these are going to be kind of rounded rectangles that will contain everything that we have in my system. Like this. The task itself is going to have a starting subtask. And I'm going to use a double rectangle shape to do this. When I do this, because I'm terrible at drawing, I'm going to draw it like this. So like the double part of the rectangle just has these extra little ends on it. Coming out of all subtasks are going to be a description of, these are the things that the person using our software is providing to us as input. So I'm going to draw a thick line here. It's just a solid line. And what I'm going to do is label with inputs. So labeling with inputs here to me is going to be high-level description. I'm looking for username. I don't know what the type of this is. I don't care what the type of this is. This is what I'm asking this person to enter. I'm asking for coordinates. I don't care what the format of that is right now. I'm just asking this person to type coordinates in or choose something on a map. I'm not going to specify how this is actually accomplished by that person. This is the input that I'm asking them for. With this ending arrow here, what we're going to wind up doing is some kind of processing. I'm going to mark this up in a different color here to indicate this is not something that I'm expecting to put in here, but processing is going to be high-level description. This is a high-level description of the processing, and ultimately what this is going to turn into is probably a method. It will probably turn into a method. And so this is something that you could reasonably think of as the processing step describes the name of the method that it's going to become. The processing step is always going to provide some kind of output, and we're going to use dashed lines to do that. And what I want to be able to mark up here is I want to label these lines with outputs. The outputs that I am thinking of here are both, these are the things that I want to display, like I've accomplished your task, like thumbs up, big success, but also things like there were validation errors in your input. You gave me invalid information and I don't want you to proceed past this point. Labeling with outputs. And then the final thing that I want to have here is going to be a subtask. This is some other subtask in my system. So subtasks are going to be like the intermediate steps that are necessary to accomplish this thing. I'll have a solid line here. Label with inputs. To some other processing task. And then finally, what I want to be able to get to in the end is an ending subtask. Can you repeat that, please? Yes, okay, so what I do want to be able to have is that the starting and ending subtasks are the double rectangles, but there might be subtasks within this entire flow that are not the end state. This is not where I've actually accomplished this task. This is just the part where I need to get more information from you about what you're trying to do. Yeah, but thank you for catching that. With the labels and the lines that we've got here, I'm going to change colors. I want to be clear that there can be more than one line coming out of each of these processing subtasks. This one here effectively goes from the starting subtask all the way to the ending subtask. But what I may want to be able to say as part of this is that the output really ought to be go back to that starting point. The information that you entered here is invalid, so you can't proceed. You have to go back to that starting subtask and then get asked for that same information again, potentially showing information to that person that you've messed up with your input here and you can't proceed past this point. Yeah. Can you start again, please?
So this is not a question regarding this part, this is regarding the project, because in the beginning you said you have specific timings for people for help center that are especially made for this courses.
This is a random question to bring up. I appreciate your question. I don't remember saying that. I believe I did. I believe you when you say I did. I don't remember saying that though. Can I answer your question after class? Thank you. Thank you. So there can be multiple different outputs from one of these processing steps. There's typically only going to be one arrow that goes from a subtask to a processing step indicating what the inputs are. There will typically only be one starting subtask, and there will typically only be one ending subtask here that effectively says you've accomplished this task. I will share this with you on the course webpage after today's class. What I want to do next class, just give me one more second here, is I want to step through this. I want to step through showing and modeling the flow of interaction of this specific system. And the way that we're going to step through this specific system is to start thinking about the kinds of things that this system is asking us for as inputs, what our starting state is, and starting subtask and what our ending subtask is in this system. So at this point, what you should be able to do is, again, kind of continuing, you should be able to choose and use appropriate language structures for representing model objects. We haven't quite gotten to this point yet. We will do that on Wednesday's class. And at this point, you should begin to informally be able to sketch this flow of interaction using the agreed upon symbols that we're using for this thing. I hope you all have a great rest of your day, and I will see you all in Wednesday.